Welcome to 2016 question C1. It's the geological geometry question. So in this question we've got the company map as shown, and they're telling us it is the plan of a garden with a swimming pool. And the ground contours are all at 1 meter intervals, which you can see here. On the map, ABC is the edge of the pool and is level at an altitude of 5 meters. So A, B, C, D, right, that's the edge of our pool. Right, this is the garden, this is obviously the pool, and it's all level 5 meters. So you say B is at 5, C is at 5, D is at 5. Using slopes of 1:1 for cutting and embankments, okay, show the earthworks necessary for accommodating the eastern side. So we've got cut 1:1, fill is also 1:1. Okay, and note earthworks from A and B have been completed for you, so we've got A to be done for us already. Okay, so we are going to look at B to C first of all. Okay, BC is 5 at 5 meters. Okay, and we're going to be, if we look at contours here, we are going to be filling. Okay, even though it doesn't really matter because it's the same for both of them. So we're going to be filling. So imagine this is the level of our pool, and we're going to be at 5 there, coming down to 4, and then 3, and so on. It's going down 1, 1, 1. Okay, so 1 meter intervals, we're going to be measuring out 10 millimeters at a time. So we're at 5, 4, 3, 2. There's no 1, so that's fine. Now this is obviously a curve. We've got center O. So at O, I'm able to rotate around. Four, my 3, and my 2. So that's 4, 3, 2. There's no 1, there isn't. So here are my contours. That's 5. We're at 4 here. 3, 2, 2, 3, 4, and back to 5. So that is my fill. Okay. Then we're also level here from C to D. If we're looking, it's cut. Cutting into it. So we're at 5, and we're cutting up. My out 1, up 1, so that's going to be at 6 and 7, right, and so on. So the measurements there are already done. First, it's level with the side of the pool. So track our lines horizontally straight down. So we're at 5, 6, 7, 8, there's 9 there, so another 10 millimeters, which are 9. So we're at 5, 6, 7, 8, 9, 9, 8, 7, 6, and then that's 5 until coming back to there. So okay. So next up, we've got part B. So DE is an edge of a sloping path. So D to E is a sloping path. At D, the pathway is an altitude of 5, which we know. and falls uniformly to an altitude of 4 meters at E. So E is at 4 meters. Okay, so we're dropping 1 meter as we go along. Using the same slope, same side slopes as above, so as we've got here. Show the earthworks, and we're telling us it's cutting that's going to be happening. So cutting is necessary to accommodate the northern edge of the path. So just a little sketch going to show what's happening there. So we've got our pathway sloping down from a height of 5 at D down here to 4 at E. Okay, so we're going to need a cone here, cut cone. Okay, that's going to be so. Now it's a cutting cone, so the radius is 1:1, so it's going to be a radius of 10, and because of the thing being 1:1, and our first line on that cone is going to be at 5. You can see. Okay, we're cutting cones, so cut at the foot, so that's why I've got it down here at the base of our slope. So start off with our radius 10 millimeters. Here at E. Okay, I can draw my contour here. Okay, and that's at a height of 5. So now I'll just put any cutting, so I'm going to be going out 10 millimeter intervals, so 10, 10, 10, one more, 10, so parallel to that. Okay, so our 5 there, 6, 7, 8, and 9. So at 5, we're up to 6, 7, 8, 9, 9, 8, 7, 6, and 5 is coming off the page here. So draw that contour. Like so, and that just continues somewhere off the page. Okay, so that is part B completed. On the southern end of the road, sorry, on the southern end, the floor slab of the pool is sloping and is uniform thickness. So here's our southern end of the pool, right, north, south, east, west, southern end. R, S are 2 points on the floor, so R to S are 2 points on the floor, right, and it's sloping. The altitudes are 4 and 3, so R is at 4, S is at 3. A vertical borehole at S reveals the top surface of the pool floor slab at an altitude of 1.5 meters. Okay, so a vertical borehole straight down there into S. Okay, if you go down 1.5, finds it. And then the strike on the floor is north 55 degrees east as indicated by the line L. Determine the dip and thickness of the floor slab. So they've given us the strike line, so we want to project out there and find an edge view of RS. Okay, so let's start with set squares. 5 degrees, and just project out R. And S. Okay, and this one. So that's right here to get a XY line. So X1, Y1. Okay, they're telling us that R and S are at heights of 4 meters and 3 meters. So that's R, that's S, that's our edge view of them. Okay. Now, that has our edge view of those. Now, back to it, the vertical borehole at S reveals the bottom surface of the pool floor slab at an altitude of 1.5. Okay, so vertical borehole at S, if we go up 1.5, so 15 millimeters, that is the bottom of our floor slab, or of our pool base. So what we're going to have now is our pool base is a uniform thickness, just to show you that, sloping and is of a uniform thickness. So that means we can run a parallel line here to show the base of our pool. Okay, and the thickness thing is going to be perpendicular. Let's draw a perpendicular line to show it. So this is our thickness, and it is 14, so 1.4 meters. So thickness there is 1.4 meters. And they also ask us, so that's the thickness of the floor slab. They also asked us for the dip. So the dip angle in is this angle created. So if I extend that, it's going to be off the page. So I'll just create a horizontal line here. So that's my dip angle. I'll measure that angle in. And it's 17 degrees. 17 degrees. My dip. Okay. So that is part C completed. Okay, this is an interesting question. Okay, things are presented a little bit different to what we've seen in other years. Last bit. So we've got, there are 4 entrance steps to the pool. So here are 4 entrance steps. The top step is level at an altitude of 4.8 meters. So top step here is 4.8 meters. In the space provided, draw the vertical section or vertical profile through the steps and the floor slab along the line PS. So from P to S, they want us to show a vertical section where it's going level at 4.8, and there's the steps down with our sloping section in from R to S. So show the steps, steps are to be of equal height. Okay, and there's 4 technically. Okay, so P to Q is going to be at that height of 4.8. So at 4.8. Right, so if I measured down 0.8, you know, R is at a height of 4, S is at a height of 3. So if I measure down 0.8, I'll be able to locate R and then S. Measure down 8. Millimeters, yeah, and I'll just measure down from that. I'll measure down another meter just to show the height is 3. So that's 4 and 3. Okay, so R straight up here to a height of 4 meters, S up to a height of 3 meters. So that's our R at 4 meters, S at 3 meters. And that's uniform thickness, uniform sloping. If I can draw that. That's the sloping surface there. Q then down to R, we've got 1, so we're at 4.8, then we'll be going to 4.6, so 4.6, 4.4, 4.2, down to 4. Okay, so every 2 millimeters here is the change in height. 3. Okay, so every 2 meters the change in height there. That will, sorry, let's drop my square. So every 2 meters change in height for each one of those steps. Okay, and project that up vertically. So first step goes down to 4.6, then 4.4, 4.2. So let's draw on those steps, each one there. Okay, so that's our profile, each step coming down, and our slope and surface then from R to S. Okay, and so that is everything completed on that one also. So nice question there, and nice to have a little bit, something a little bit different to previous years, it being a pool instead of roadworks.